Okay, for this section, we're going to do factor by grouping. So when you have four terms, you can group terms in pairs to see if you can factor it by grouping. You also need to take out the greatest common factor first if it has one. So for this one, we've got MP plus 3MQ plus NP plus 3NQ. So you can rearrange terms if you want to put things together the way you want. Usually I try just splitting it in half and seeing if I can factor it by grouping that way. Sometimes you would have to rearrange the terms. Most of the time, if it'll factor by grouping, you can just split it in half. So we're going to break it in half here. We're going to factor out what you can factor out from each pair, because this one doesn't have there's nothing that all four terms have in common, so you don't have a greatest common factor to worry about. So for the left hand side, MP plus 3MQ, they both have an M, so you can factor out the M. And you're left with a P plus 3Q. And then for the right side here, NP plus 3NQ, they both have an N, so you can factor out an N. And you're left with a P plus 3Q. So then you see that you have two pieces here, and both of them have a P plus 3Q. So you factor it out just like if it were MX plus NX, you'd factor out the X. So you factor out P plus 3Q, and you are left with an M plus an N. And you could FOIL this to multiply it back out to make sure that it does work. You can FOIL. So first, P times M is MP or PM there. Outer P times N is NP, which is here. So this is addition, so it doesn't really matter which way what order the terms are in. 3Q times M is 3MQ, which is here, and 3Q times N is 3NQ, which is here. So that does work. So you can always FOIL it back out to make sure it works. For the next one here, so for this one, you have a 3, a 6, a 9, and a 12. So you can take out a greatest common factor here. I didn't on the handwritten notes because this is actually not going to factor, but I will here. So if you take out a 3, you're going to be left with n squared plus 2n plus 3m cubed plus 4m. So divide each number by 3. And then if you break it in half, you're going to have 3 times. Out of these, you can factor out an n. You got an n squared and a 2n, so you got n squared n, and you're left with n plus 2. Plus, out of these two, you can factor out an m, and you're left with 3m plus 4. So now you have an n plus 2 here and a 3m plus 4 here, and so therefore you cannot factor this by grouping because they do not match. There's nothing in common, so that's about as far as you could go. So you can just say cannot be factored by grouping. So all you can do is factor out the greatest common factor of 3, and that would be it. For the next one here, you have 8x squared plus 16xy minus 5x minus 10y. So again, split it in half. So you would have here 8x squared plus 16xy. You can do an 8 and an x. And you're left with 1x. And then 16xy, you take out 8x. You're left with 16 divided by 8 is 2. The x is gone and the y. And then for these, usually you do have to factor out negatives in order to make the signs match. So you got a minus 5x minus 10y. So if you you can take out 5 and 10, you do a negative 5, and that would be all. So it's going to switch these to positive signs. So you'll be left with 5 is gone, so you'd be left with a positive x. Negative 10, you've taken out a negative 5, so you'd have plus 2 and the y. So now you see these two terms match, x plus 2y, x plus 2y. So you can factor it out times You're left with, if you factor this out, it's gone. You're left with 8x. You factored this out, so it's gone, minus 5. And again, you can FOIL it to see if it works. So x times 8x is 8x squared. X times negative 5 is the minus 5x there. 2y times 8x is 16xy, which is here. And 2y times negative 5 is negative 10y. So always check it once you're done to make sure it works. And this last one here looks really complicated, but you do the same thing. You take out split it in half and then factor it. You can also check to see if there's a greatest common factor, but there's not. None of these have all things in common. So split it in half. For the first two, you've got an a cubed and an a, so you can take out the lowest exponent of a. And then you've got a b squared and a b, so we can do a b. You've got a c and a c squared, so we can do a c. You got a d and a d, so we can do a d. And you got no x here but an x here, so leave it alone. So you got a, b, c, d. And then you're left with, if you've got a cubed, we've got an a out here, so a squared. B, take b squared, take out a b, so we got a b left. C's gone, d's gone, so that's done. Plus, a's gone, b's gone, c squared, we've taken out one c, so we've got a c left. D's gone, and we've got an x left. Then on this side, they're both negative, so we can take out a negative. We've got an a squared, no a here, so can't do anything there. B, no b here, can't do anything there. X, you got an x squared, so we can take out an x. And y, we got a y, so we can take out a y. So you're left with a squared, b, the x and y are both gone, minus c, x squared, we've taken out one x, so we've got one x left, and the y has been taken out. So now you see these two things match. So we can factor it out, and we're going to have a squared b plus cx. And then what's left is, if you've factored this out of this factor, it's gone. You've got a, b, c, d. And then again, you've factored this out of that, so you're left with minus xy. And again, you can check it if you FOIL it back in. I'm not going to do it this time. But if you FOIL this, first outer, inner, last, it does give you all those terms, so it does work.